So with example C here, if we follow the directions, examine the graph, can you connect the two parts of the graph with a vertical line? The answer is no, and that's because there's a gap in the domain. Let me show you how there's a gap. I'm going to go here to this part. This first one. This is the x minus 1 line. I know it's the x minus 1 line because it's the one with the positive slope. Notice that positive 1 in front of that x. So this is that line right here. And it's starting right here on the x-axis, and it's going this way. So it's using x values that are greater than 3. That's the part of the domain. That's what that part right there is. It's only using x values that are greater than 3. This one is only using x values that are smaller than 2. So smaller than 2 is this part of the x-axis. So smaller than 2 deals with this line, greater than 3 deals with this line, and you can see that there is a gap right there in between those two. That means there are no values of y for x that values that are between 2 and 3. So if they ask, can you connect this with a vertical line? The answer would be no, because if I draw a vertical line right there, oh, it's really hard to draw it straight. If I draw a vertical line right there, you'll see that it doesn't touch this branch of the graph and it doesn't touch this branch of the graph. So, and is that a problem? No. Is it a function? Yes, because it passes the vertical line test. It doesn't matter where I draw a vertical line. Any of these vertical lines are only crossing my function at one place, one place, one place, one place, one place, one place, one place. So it is a function. It is not a continuous function, obviously, because it's in two gaps, but I do have a break in the domain. Not a problem, just something that you need to recognize and be able to talk about. So you might, again, finding, let me see if I can erase all of this over here. Finding a value graphically should be pretty straightforward. Which value would you like to find graphically? I don't know. Since this is a function, let's rewrite it in function notation. We can change this to an f of x. Why? Because it is a function. We can find, let's do f of 5. We find f of 5 by going over here to the 5 and then going to where we are on our function. There we are right there. So the y value, when the x value is 5, the y value is 4. So f of 5 right here is 4. Let's do another one. Let's do f of negative 2. Okay, so let's go to negative 2 on the x-axis. Negative 1, negative 2, and we don't have to go anywhere because we're on our line right there. So the y value when x is negative 2 is 0. We could also, of course, handle each one of these algebraically. The 5 is a number that's greater than 3, so we would plug the 5 in right there. 5 minus 1, that's where we get our y value of 4. Negative 2 is a number that's less than negative 2. So we'll plug the negative 2 in right here. So negative 2. This negative goes right here. The 2 that I'm plugging in is a negative. So we have minus a negative and then negative 2. So those two negatives make a positive, positive 2, negative 2. I can algebraically calculate that to be 0. All right, so the last thing that I want to talk about is how you can put these on Desmos, because we are lucky that we can put these on Desmos. So I'm going to use the example C right here to plug it in. You can do y equals, and but you don't have to. You could just put in the x minus 1 part. You know how Desmos works. As soon as you type in the x minus 1 from this part right here, the x minus 1 gives you the whole line. We do not want the whole line. We only want the part that starts at when the x values are 3. So what we're going to do is be sure you use the correct symbol, and it's this bracy thing right here. You don't have to open this keypad. I'm just opening it so you can see what I'm typing in on my keyboard. I'm just using my keyboard to do that. But you have to open this little brace. That's what I call it, a brace. And then you're going to type in whatever restriction that they give you. So I'm going to type in X. I'm going to go back to the keypad here to get less than or equal to. You do know, in case you don't know this, you can't see my keyboard, but if I just use my keyboard to type in that, and then I type an equal sign in afterwards, do you see how it just put the bar underneath it? So that's one thing that you can do. Let me back up and show you that again. So I'm trying to type in X is greater than or equal to 3. I typed in X. You can use the greater than symbol and then use the equal symbol, and it puts the bar underneath it. So I'm typing in X is greater than 3, and now it shows this line right here that I graphed. It shows it over here. Now, the only thing that it does not do is it does not define whether or not that endpoint is included, but you can tell by just clicking on your line and drawing down to the end, and it's included because there is a Y value there. Let me show you what I mean. If it wasn't included, if it was just less than 3 and I clicked this and drug it down, when I got down to 3 right there, it would say undefined. Why? Because there should be an open circle right there. Now, it doesn't graph it for you. You can graph it, but you can also see. So if your goal is to graph it and turn the graph in, then we would want to put a point right there, and I will do that in just a minute. But right now, I want to make sure that you know that to type in the other part of this PieceWise function, I have to go down to a new line, and I'm going to type in this equation right over here. So I'm going to do negative X minus 2. It gave me, again, the whole line. I don't want the whole line. I just want the restricted part. So I am going to get my little bracy things back, and I'm going to type in the restriction. X is less than or equal to 2. And when I do that, again, it is graphing it for me. I want to check my endpoint to see if it's included or not. This endpoint is included. And so if I wanted to plot those, I would have to go down to line 3 and then simply type in the ordered pair. I think it was 2, negative 3. Oh no, I was wrong. It was it is negative 4. Sorry, negative 4. And we would do the same thing for the other one. This one is at 3, 2. So we would type in 3, 2. Whoops, I did miss my comma. 3, 2. And of course, I don't know about y'all, but I might want my dots to match. So the line, so you click that, and then you go to this green dot and say, hey, we'd rather that be blue. You click the purple dot and you say, hey, I'd rather that be red. This is where if you want an open circle on there, you could certainly put an open circle, but be careful. Just because you put an open circle, that does not mean that it matches what, so you see right there, it should not be an open circle because there's a value right there at 3, 2, and I get that by tracing it. So if you trace it and it gives you a value, then it should be a closed circle. If and I go back there to make it be a closed circle. So if there's a bar underneath it, it should be closed. If there's a bar underneath that one, it should be closed. And if you want to find values of your function, like over here we said f of 5, then you simply click on the graph and drag it until you get to 5, and then it'll give you the y value. Okay, if you want to find out what the value of f of negative 2 is, you just have to click on it, drag it until it says negative 2, and then it gives you your y value. So Desmos is very helpful when it comes to piecewise functions.